on one half of the breaker that basically saved you from a fire. In my case, and I can show it to you in just a moment, the heating coil did actually fuse itself in half in several places and then tried to weld itself to the lint covered sheet metal inside the unit, which can cause a fire if the breaker does not trip, or of course if the lint catches fire first. Okay, let's get started. So first of all, we disconnect power. This is 220 volts. This goes directly to the dryer. It powers the heating element inside as well as the electronics that just turn the motor to spin the drum and the buttons and lights. Many dryers you'll see a panel on the bottom here. Some the heating element will be directly in the back inside of a sheet metal box. Those are the videos that I saw. Had a lot of heating elements directly on the back. In this case, if you see a lower section, most likely it's going to be down here. It's very simple to get to. There's just 2 screws on the bottom. In my case, you can either use a screwdriver that has a 1/4 inch tip, a replaceable tip. You can use that, and the 1/4 inch or the 1/4 inch size fits it, or you can use a screw gun or drill driver. So we just go ahead and pop this off. Inside you will see there's a bracket here which leads to a duct up inside, and inside the duct, that's where the heating element is. Now it has several sensors on the side, and I strongly suggest that you take a picture of the wiring as you can get a better view. So when you pull it all apart, you make sure you have the wires exactly in the right spot. So here we go. There's this bracket right here. It has a screw here, a screw under here, and then this bracket will come off, and the duct that holds the heating element will be visible right there. That actually just clips into the back of the unit, and we can slide this a little bit forward. And I already did this previously, but I would have taken a still photograph of these 2 sensors, and this is your heating element connector here. This sensor, I believe, is the thermostat, and then this is a high heat or overload temperature setting. So either one of these, basically one of them keeps the temperature at the correct range, and if this ever burns out and it gets over hot, this sensor will also shut it off. To test either of these sensors, you can hook your meter in the ohms category, touch the black and the red, either or, doesn't matter. It will start out with a higher number, let's say like 10, and it'll work its way down to 0. And if it does that on both of them, then they are working correctly. So next we can pull this right on out. Let's see. Now I already took a few of these screws off, so I'll just take the last 2 off. Now there's a screw here, one here, and another one there. And then all you need to do is take off one on the top of each sensor here. One here and one here. And the top of the sheet metal box, or this, I should say, this duct is removable. You just lift it straight up. And here we have a single heating coil. So it basically has one wire going in and the other wire that comes out the other terminal. So here we can see this one has got some burning. The house is 18 years old, so I don't know if this is the original unit to the house, but I'd say it's probably at least half of that, so it's at least 9 years old. So here, just pop this unit out, and there we go. We see real close, we can see the heating wire is broken in half. It's supposed to be a complete circuit, so it should be connected right there. It fused in half right there and burned up, and then what it did is it touched the sheet metal, welded itself there, and of course that ground tripped one side of the breaker, the side that heats this coil, and left the opposite side of the breaker, because it's a 2-pole breaker, left the opposite side on to run all the electronics and the motor. So that right there will tell you one side, the breaker saved you, and that this is likely what's going on, is just a burned up element. So what I then did is as previously stated, I tested these two sensors. They both ohmed out correctly, so they have a complete circuit, and it looks like they're still good. So what I did was I went to the computer and looked at my serial number, which can be found. Open the door. Let's see here. Right there. Look at the model number, and I took that to took it to Google, and you can go start with Google and look. You can find parts diagrams, then you locate your part, and sometimes they show a little picture of the part, and you can verify, if it's authentic, if it's a Whirlpool or GE. A lot of companies will use the same exact one, so this could fit literally hundreds of models of washers and dryers over the last 40 years, and it's the same exact thing. I later found out if I went locally, it's about $120 to $660. I went with an appliance place online, I searched an appliance place online. I cross-referenced the part number that I did find. They wanted like $120 to $160 for a couple of different places. I went on Amazon. I verified the part number. I looked at the picture. It was identical. I read the reviews. Turns out it was a Whirlpool part that's made of OEM by Whirlpool. Fits a Kenmore, fits all these other brands, and had high ratings. And it was only $40. You can't go wrong with an original high quality part. I saw some that were $24. Some of the reviews said cheap part, blew up in 2 days. Other people said, oh, it lasted. My guess is those people got lucky, or they reviewed it before it burned up. So I'll take a break and I'll show you how to replace this.